Very good morning, everyone. The next topic is DFA. DFA is the abbreviation of Deterministic Finite Automata. It is commonly known as the DFA. It is one of the fundamental concepts in automata theory. It is used to recognize the pattern in a strings. The term deterministic means that the system behaves in a completely predictable manner. In a DFA, for every state and every input symbol, there exists or exactly one definite transition to the next state. This means that the any point in time, the machine knows exactly where to go the next or without any confusions or multiple choice. A DFA consists of a finite set of states, an input alphabets, a transition function, an initial state, and a set of final or accepting states. The transition function plays a key role. Here it is a map each state and input symbol to exactly one state, so ensuring that the computation follows a single path. To understand a DFA more clearly, let us consider a simple example. Suppose we want to design a DFA that accepts all string containing the pattern of 0, 1, 0. The DFA starts from an initial state and reads the input strings one symbol at a time. When it reads 0, it moves to the next state, including the possible start of the pattern. Then if it is read 1 in a transition to the another state, showing a progress toward matching the patterns. Finally, it read the 0 or another, it reaches the accepting state, which means the pattern like 0, 1, 0 has been successfully found. If at any point the input does not match the accepted pattern, the DFA transitions to the another appropriate state and continuous processing without stopping. The important aspect here is that the DFA never guesses or explores the multiple paths. It very strictly follows the one path based on the defined rules. Another important features of a DFA that is does not allow a epsilon transition, which means it cannot change state without reading any input symbols. Similarly, every move must be triggered by an input characteristics or character. This makes a DFA simpler to the implement and easier to analyze the compared to the non-deterministic model. We already know what is the non-deterministic and how it will be work into the deterministic finite automata. The model will be very simplicity. However, it can sometimes need to a large number of states when solving complex problem, especially when compared to NFA. This NFA is widely used in a practical application such as lexical analysis in compilers. The pattern matching and text processing because of its efficiently and predictability. The proof in terms of string acceptance of a DFA accepts all strings only if after they processing the entire input. It ends in one of the accepting states if it is end to the another state. Then the string is rejected. This is a clear and strict acceptance conditions ensures, so that the DFA provide a definite answer for every input strings. It will be multiple converting an NFA to DFA, but we cannot convert to DFA to NFA. The conversion only begins to NFA, then to DFA. In the summarization part of a DFA is a precious and structured computations model that follow a single or well-defined pattern or path for each input, making it reliable and easy to implement. Its deterministic nature ensures that the every input of DFA it exactly one computation path, which is why it is called deterministic finite automata. Thank you.